So as an example of how to use this integrating factor to solve a first-order linear ODE, let's solve this one. X squared plus 1 times y prime plus 3xy equals 6x. Okay, so step 1 for our method is to rewrite in the proper form. And so this factor of x squared plus 1, that needs to be moved over to the other side, so we just have y prime by itself. So I will divide that across, so then I've got 3x over x squared plus 1 times y is my 6x over x squared plus 1. And now that I have it written in the proper form, I can easily identify that this part here, this is my p of x, and this part here, this is my q of x. Okay, so for step 2, I need to compute the integrating factor. So I'm going to need to integrate 3x over x squared plus 1 dx, first of all. So let's see. So this is, well, how do I integrate such a thing? I'm going to do a u substitution. And so I can see that if I take u to be this denominator right here with the x squared, then when I differentiate that, my du is going to be ready and waiting for me right here. So I will go ahead with that, and doing that u substitution, I get the integral of 3 over u times 1/2 du from the 2 that comes down when I differentiate u. And so that's, let's see, so that's 3/2, and then the integral of 1 over u is log u. And I'm going to take my constant of integration to be 0 because, like I said, it doesn't matter. That's what we saw last time. So then this is back in the original coordinates, log of x squared plus 1. So my integrating factor mu is going to be x squared plus 1 to the 3/2. Now we go on to step 3. So for step 3, I'm going to multiply this x squared plus 1 to the 3/2 across both sides of the equation. So I have x squared plus 1 to the 3/2 times y prime. And then I'm going to have 3x x squared plus 1 to the, and now I've got 3/2 minus the 1 in the bottom, so that's a total exponent of 1/2. And then on the right hand side, same kind of thing happens. There's an x squared plus 1 in the denominator, so that's going to cancel one factor of this thing and just leave me with a 1/2. Okay. Now it's time for step 4. So first off, what I do is I just write d dx times, and then this should be my integrating factor, my mu. So mu is x squared plus 1 to the 3/2 times y. That's what it should be on the left-hand side. So first off, I just write that, and then I check to make sure that it's actually true. Okay, so what do I mean by that? Well, let's see. If I do this derivative, then there's going to be the part where the d dx attacks the first term right here. So this guy gets differentiated. It's going to bring down the 3/2. So there it is right there. There's 3/2. And then I'm going to be multiplying by the chain rule, a 2x coming out of here. So I have 3/2 times 2x, and those 2's cancel, times x squared plus 1 to the 1/2 times y. Great. And then I have from the product rule the other part where the derivative attacks the y, and that's exactly this one that I have right here. Okay, so after having mentally done that computation and seeing that it works, then I know that we are good to go for the next step. That's my double check, successfully completed. So I go on to step 5. So I integrate both sides, and on the left, it's as simple as just writing it without the derivative sign out front. And on the right, then, I have to do some kind of work. So let's see, so I've got 6x, let me split that as 3 times 2x, x squared plus 1 to the 1/2 dx, just because I can smell that there's another u substitution coming. So this is my u right here, and then since there's an x squared in there, this part right here will be my du from the change of variables. So then I can integrate this, and this will be 3 times integral of u to the 1/2 du. So that's 3 times 2/3 u to the 3/2 plus c, which is 2 times x squared plus 1 to the 3/2 when we convert back to the original variable. So we've got this guy. And now this constant of integration is important. Must keep that one. Okay. And we really see why it's important in the 6th and final step when we actually solve for our unknown function y. So what do we need to do here? Well, we just have to take this integrating factor mu here and move it to the other side of the equation. So I divide across by that, and that leaves 2 all by its lonesome. And then I have c over my integrating factor, x squared plus 1 to the 3/2. So you see, if I didn't have that c there, this whole interesting term would have been lost, and the bulk of the solution would be missing. I just have the constant 2, and that would be lame.